What type of solenoid valves control parts of the airlines that could cause in a failure to crash an airplane? Is there anything that a solenoid valve operates that if it failed, it could cause a plane to crash?
No, that's not the case.
So,
It's normally those aircraft are multiple systems, and if one system fails, it's not going to affect anything. So
right.
most of the time, it's about 3 or 4 systems that are used.
Oh, I understand. But I mean, if more than one solenoid valve failed at the same time, could it cause a possible crash? Or if like a fuel valve?
Yes, it could. Then you had to be very unlucky, I would say. But,
right. But
yeah,
it is possible. I mean, with intermittent problems, you could have one valve that appears good and an intermittent problem, and if the good valve failed and the intermittent one, it would be bad luck, but it could happen.
Yeah, like you can say Murphy's law. Yeah.
Okay, right.
Yeah.
Well, so
right.
basically, really, what we're dealing with the tester is more just delaying flights.
It's
if solenoid valves aren't operational, they have certain procedures and backup plans where certain valves should be working when it's in the air.
Correct. Some of the valves can be not working for let's say up to 10 days.
Okay.
That's according to the manufacturer differentiation guide.
Right.
But and some valves you simply can't go. So for example, fuel. So some of the fuel valves.
Oh, I see. So
and,
it's a safety thing. Safety.
Yes.
Issue.
Yes, but everything is different. For example, APU bleed is it's not essential.
Right.
Yeah.
It's so if the solenoid valve for the APU is not working, it's it will not it's like a good thing to have.
Right. So they won't clear it for takeoff until it's fixed.
For the bleed from the APU, it's not essential.
Oh, I see.
So the bleed. That's you mean the main fuel valve, right, for the APU?
Yes, but yeah, let's say if you have a broken a bleed valve, then you don't have any air. But then you can, on the other hand, run the APU, and if you don't have a working solenoid valve for the APU, you will not start the APU. So it depends. It depends which system you are looking at.
Okay, I understand. Mr. Johannsson, the Mag-Probe's primary use for you using it on the aircraft would be on what solenoid valves do you feel that you're going to use it on the most?
I would say bleed valves and fuel valves. That's the most common so far.
Okay.
And of course, what I really like are the to check relays.
Oh, protected relays, right? Those are encapsulated.
Yes, they all are, but the Mag-Probe can easily find out. Those relays are closed in a metal casing, but anyway, the Mag-Probe can read it.
Right through the casing.
Yes.
Does that save you any time?
Yes, it's quite important during troubleshooting to find out if the relay is energized or not. If it's energized, something else is wrong.
Yes, right, exactly.
Yeah. I don't see that Mag-Probe would be used in periodic tests. I would say Mag-Probe is very useful when you have something wrong and if you have any problems, I would really like to have the Mag-Probe near, but during those tests, it's all built in. For example, we can do a lot of tests in the cockpit, but when something is wrong, then you need the Mag-Probe.
Oh,
Right.
okay.
Well, because time is money
Yeah.
for the airline, so any delayed flights can cost them a lot of money.
Yes, correct.
Right.
And
So if you have a problem that you can't resolve, and you need to check a lot of solenoid valves to make sure everything is working, you can check them really fast, and get to the bottom
Yes.
of it and separate electrical from mechanical, so you know which direction to go in.
yes, and
Okay.
and you don't have to remove any relays and go deep into the drawing to find out if it's energized or not.
So it avoids you having to go through a schematic and be very analytical about the schematic. You can just hit one relay after another to make sure everything is in sequence, operating correctly.
Yes, correct. When I'm doing troubleshooting, I like to print out the schematic and see how many relays are in the system,
Right.
and which one should be energized, so when you know when you look at the drawing and you can see that this relay should be energized, and if it's not, then you have
right.
a good lead.
Right.
Yeah.
So basically, you can isolate the mechanical electric problem at certain pivotal points where it's shifting electricity into another line.
Yeah, for example, a fuel valve.
Okay.
If the fuel valve is energized, then it's most likely a mechanical problem of the valve.
If there's a delay in the activation of the solenoid.
Yeah.
Yeah, I have seen that. I've seen that when the valve is stuck,
Right.
then suddenly it moves. Yeah, I've seen that.
So when they run, they don't turn on right away. They may turn on. Another thing is different times. If you see the light turns on, and one time it turns on right away, and the next time it turns on at a different time, say 1 or 2 seconds later, something's hanging up in between.
Right.
Yeah.
Okay.
So it would probably most likely be a worn contact, possibly, right?
There
are. Yeah, go ahead, Bob.
Or no power to the contacts of the relay.
Well, what I was saying is if the solenoid valve is energized and you're getting a reading, you got current, continuity, and voltage all at one time. That means that you have everything that's required to make the contacts close to make it work. So if it doesn't close immediately and it pauses, then there's some form of a mechanical failure.
Yes, correct.
Whether it be
or you don't
contact,
or you don't have power to the relay contacts, but at least it isolates it, so you know that it's getting the signal to the relay, and it's something to either the contacts or no voltage to the contacts.
Right. So what problems do you find when it's energized mostly on these valves usually? If the valve is energized, what kind of mechanical problems do you usually see on these fuel valves?
There are those fuel valves are it's called butterfly valves.
A butterfly valve.
And in many cases those valves get stuck, and like I told you before, there are in some cases a no-go.
Yes. Okay. I understand that.
Okay.
Yeah.
And is it your understanding that what's causing mechanical fuel valves to get stuck, is it like dirty fuel possibly, or something in the fuel that causes it?
No. It's no. I wouldn't say that.
Okay.
It's just worn because
okay.
those valves are operating many times a day.
Right.
So those valves get worn. Yeah.
Okay. So basically, it's just old valves that have been in there a while.
Yeah.
Okay.
And also in some cases we have a new valve from stock. It's only been there for maybe 300 flight hours, and they fail. So
wow.
Yeah.
The customer called me up and he said he had a problem. He was reading a valve without any power applied to it. And I said, "Are you sure there's no power applied?" He said, "Yes." He says, "Right here on the bench, the leads are loose, and I'm still getting a magnetic reading off the coil." And the only thing I said, well, probably is the coils, the little bar that runs in the coil is magnetized, is not losing its magnetism when you turn it off. So I said, "What did you do?" He said, "Well, I pulled out a new valve out of a box, brand new." And he said, both of them were brand new valves, but the one he got out then, he said, "I checked it and it didn't read a voltage on it, and I put it in and it worked." He said, "So," I said, "It's what happens sometimes when they manufacture these, if they get a contamination in the materials they make the cores out of, they don't completely demagnetize. So every time you take a valve out, you should test that with a Mag-Probe before you install it." Okay, Mr. Johannsson, let me ask one question of you.
Yeah.
What do you think the savings is in percentage over going to schematics and using voltmeters to troubleshoot in relationship to the Mag-Probe?
I would easily say about 80-90%.
90% faster?
Yeah.
Okay, I figured that. Well, I did it too, so I know, what a pain it is. You get out the schematics, you got to follow the wires all down the terminal strips, and you can't stick the wires with voltmeter probes because the sharp probes will damage the insulation.
Before you started using the Mag-Probe, a standard problem like you would have that was very complicated with all the valves running and the electrical problems, how long would it take to isolate problems generally?
You would need like a ohm meter, and with the ohm meter it takes it takes a long time to go into the drawing, and with the Mag-Probe you can take that time. I would say easily 90%.
Okay.
But on the other hand, it's quite hard to compare Mag-Probe with electrical meter, because with the electrical meter you can go deep into current and voltage and everything, but I would say the Mag-Probe is very, very useful for its thing, but I would not take my voltage meter out of my toolbox. But those things are very good together.
Right. So basically, it's a good add-on for a voltmeter.
Yes, I would start with the Mag-Probe during troubleshooting, and then when I go closer into the problem, I would start to use my voltage meter.
Right. Exactly. Because basically, once you've isolated the problem and you know where it is, then you can go into a refined testing process. So basically what I'm hearing is that because you're able to separate mechanical from electrical problems, if it's a mechanical problem, then the problem's solved because you have to replace the valve. If it's an electrical problem, then you pull out your voltmeter and you start making tests to find out exactly where the electrical problem is.
Yes, it depends what is wrong, because like I told before, I've been using this for bleed valves and the fuel valves, and it's all different, and in some cases you have a ground to the valve that you shouldn't have, so it's various problems.
I see what you're talking about. So in other words, a valve could actually be activated when it's not supposed to be activated.
Correct.
So it's on when the switch isn't on.
Yes.
So what it basically does, it tells you what if right, exactly. That's really good, because that could be an intermittent problem or it could be a magnetizing problem.
And this valve is maybe works with ground, and so should close when it gets ground, and and when this valve is not getting the correct signal, it will do the opposite.
Right.
All right, thank you for that, and we keep in touch.
All right.
Okay.
Take care.
Okay, take it. Bye.
Bye.